Hello students, and welcome back to the Quarantined Lectures. Today we're going to be taking a look at materials properties through tensile testing. Hello students, and welcome back. So many of the mechanical properties that we talked about in the last lecture can be determined in a material by performing what's called a tensile test. So to perform a tensile test, and we're actually going to do one live here in a minute, but I want to talk us through it first. Perform a tensile test. A small sample of material is formed into what's called a dog bone shape. So what we have here is, this is actually the sample that we'll be doing our testing on, but we have this just little thin sheet of plastic has been carved into what we call a dog bone shape. The reason that it's cut in this fashion is because we want to force the deformation to happen in this region. Right? Where the material is thinner is where the stress will concentrate and where the fracture will be controlled. So we can make sure that it happens somewhere in this region so that we can still clamp onto it, so we can still pull it as we want. So what we're going to do is we're going to put this into our tensile test machine, and then it's going to be subjected to a load that puts tensile force on it, which means it's going to pull it from this direction and this direction. It's going to try to elongate the sample. During the tensile test, data is recorded and it compares the magnitude of the load versus the deformation of our sample. And the load is continually increased until the sample ultimately breaks. That is one thing to note about this is tensile testing is a kill test, right? We ruin the sample by doing it. You can't use it again. So what I'm showing here is just a quick schematic of the tensile test. So again, you see the dog bone sample there on the side, and fundamentally it's a relatively simple device. You have a crossbar that moves up and down and can apply the load. You have two clamps to clamp in the material, and what we'll do is we'll apply a load to the moving crosshead, and it will just slowly elongate that material while we measure not only the amount of load on there, but also how much that crossbar actually moves, which gives us the elongation. All right, so without further ado, let's go ahead in and look at our tensile test. All right, students, all right, here we're outside doing our tensile testing. Got our lab dog helping us. He's all ready to go. All right, so this is our tensile test apparatus. So as we can see, we have our crossbar, or our dog bone sample in here. We have two clamps holding it in, and then this is our crossbar. So the way that the home built system I've made works is that bucket you see underneath, what we're going to do is just add water into that bucket slowly to add additional weight to the sample, which will slowly stretch it. As we add the weight, we'll see it stretch. So what I'm going to do is I'm going to set the camera up, and then we will look at this in slow motion. As the sample stretches, you'll see it stretching in the middle, as you would expect. All right, so our testing is complete. We can very clearly see, we saw it fracture, of course, as we would expect. We have a piece down there, and then of course we have the long piece here, so you can see how much, actually let's take this guy out. We can very clearly see how much this guy has stretched. You can also see, interestingly, how he changed colors right here, right? It's an interesting phenomenon. But we have, yep, totally destroyed our sample. We got to see the tensile testing out of it. So, all right, so that is tensile testing in short. Join us back for the next lecture where we actually talk about the stress strain diagrams that come out as a result of this testing.